Hello everyone, my name is Jean Paul and this is my pseudocode presentation for the EEL2161 project. In this project, we're asked to write a script to ask the user whether he would like to see matrix addition subtraction, matrix multiplication, matrix transpose, or finding solutions of simultaneous linear equations. I'm going to be focusing on two of them. The first option will be B, and will be matrix multiplication, and then we have D, which is finding solution of simultaneous linear equations. Now on this slide, as you can see, check dimension work. So what it means is we're gonna be checking the dimensions of the two matrices we need for the multiplication to see if we can continue with the script or we can continue running the program after we are given the values of the both matrices. So on this case, I use the switch for each of my options. So on this, the case B, the first thing I do is prompt the user for the row number and column number of matrix A. And after you do that, since you want to make sure that the matrix A and matrix B have the same number of columns and rows, you do a do while loop. Now with the do while loop, what we do is, as you can see at the bottom, we state the while. It says rows A are not equal to rows B, or columns A are not equal to the columns of B. So basically what it's saying is that as long as this is true, it's gonna go back to the do while. So it's gonna go back and prompt the row number and column number of matrix B. Now inside of this do while loop, we added an if condition. So it's basically saying that the same thing. So if rows are not equals and the columns are not equal, it will display an error, and then it will end the if condition, and then we'll move to the next thing depending on what it is. So if the matrix has the same columns, then it will get out of the loop and then move to the next step. So now that we have the dimensions of our matrices, we want to get what we're going to be multiplying of the matrices. So basically the numbers that we want to put in the matrices. So if we go to the slide, we see that I started with two for loops for the row and columns of matrix A, and then I prompted the user to type in that element. So basically, in these two for loops, you get a variable, you equal it to 0, right? Because when you have an array, the first space is not 1, it's always 0. So you want to start on the very beginning, right? So you set a variable equal to 0, right? That's where you want to start. And then you make it go to as far as many rows you got. So if you say from 0 to row A and row A is 3, then it will go 0, 1, and 2. And then you have that the three rows that you stated, or that they were stated on the prompt, right? Then right after that, we can see we started an if condition. So basically, this is to check that they can multiply. If you see the rules for multiplying matrices, you can see that the column of the matrix A has to be equal to the row number of matrix B. So right here, this if condition, that's basically what it's saying. It's saying column A is not equal to row B. So it will display an error, and then you can see I ended the if condition. And in this slide, you can see we're just going to be multiplicating the matrices, right? So on the last slide, you can see that it was we were checking to see if the columns and the rows of the matrices were equal, right? Why we did that is because when you're multiplicating the matrices, you want to make sure that those are equal, because you when you do it, you multiply the rows of the first matrix times the column of the second matrix. Now, with these three for loops, you can see the first two for loops are basically the rows of the matrix A and the columns of matrix B, right? So we know we gotta multiply those two to get the multiplication of the matrix, right? Now, what the third for loop is doing is basically, since we are having the same amount of rows and columns, so with this last for loop to the column, you will do it so the matrix A will go up every time on the columns, and the matrix B will go one more up on the rows. And when you do that, then you multiply them, and you should get your result of the multiplication. Now on to next slide, we got the option D, right? We have the switch the case D. So we're gonna be solving linear equations, right? Now to solve the linear equations, we started with the two for loops, right? On my project, the unknown variables are actually known, and is a matrix 3 by 3, right? So that will be what, so it will go from 0 to 3 instead, of any other variable. But yeah, so it will go from 0 to 3 on my case, and then I have the two for loops, right? So it will go on columns and then on the rows. And after that, you can prompt the user to type in the coefficient, right? So this is the linear equation we're talking about, and you want to get the coefficients, will be the numbers in front of the variables, right? After that, you can end the for loops and start the other for loop to get the results or the constant. That'll be the constants in the equation. So the what's on the right hand side of the equation. We have those two answers, right? We have the constants, the coefficients, right? Now we gotta find what we're looking for, right? And we have the determinant formula, which is gonna help us to calculate and see. So the only way this will work is if the determinant is not zero, right? So if you go into the next slide, you can see uh, that I stated if the determinant A, which will be what was given to us, equals 0, then it will display an error, right? So with that error, um, it would just uh, not allow or move on to the next. The only way you can get the Cramer's rule to work is if the first determinant is not 0, right? After finding the first determinant, what you do now is make sure that it's not equal to 0, right? So the only way that the Cramer's rule could actually work is if the first determinant is not 0. So whatever values you put into the first determinant, you have to make sure that they don't equal 0 if you want to use the Cramer's rule, right? So what the Cramer's rule would do is basically replace, right? So how we do this is we create a for loop, right? On this for loop, what we'll do is we're gonna create a matrix, create a whole new matrix, and then that new matrix, after we have it, we're gonna equal it to the constant. So the constants will be the right hand side of the equation, right? So once we set that up and we have the new matrix and replace it with the constants, We use the determinant formula again, and we calculate it. And after we have calculated both of the determinants, we will divide the first determinant, so the very first determinant we had, we divide that by the second determinant, with the one that we just created with the replaced constant, right? Uh, so once we divide it, we end the for loop, and then we will display the results, right? And that will get you the solution for the linear equations.